Geotrig, this is day 4 of lesson 14. I would highly pay attention to what's going on today because it's going to make your life a lot easier. So guys, pretty much everything that you've done for graphing-wise in math has been of the rectangular coordinate plane, the xy, right? If I gave you the point xy, types, order pair, it's right there, the order pair right here, of xy, negative 3, 4, you guys could graph that. If I gave you an equation of y equals 2x plus 3, you can graph that by getting some ordered pairs, drawing a line. That's fine, that's fantastic. Now, what there also is there's one that's called polar coordinates. Polar coordinates, guys, work slightly different. Polar coordinates is about rotating on a certain axis and then walking to your spot. Actually, hold on. Oh, sorry, before we even get to there. So that's true about polar. We also have i's and j's. And it's I hat, j hat, eventually, where I indicates the x direction, j indicates the y direction. Don't get that confused, guys, with I being the square root of negative 1. So technically, I'm going to modify this, okay? I'm going to put a little hat above it. They're little carrots, okay? So we place a little bit of caret above the I and the j. This denotes I hat, j hat, your x direction, your y direction. Okay? So again, we'll get to polar next. So in rectangular form, we have two versions. You have your order pair, x, y, and you have I hat and j hat. And the really cool thing about the I hat and j hat is they have the i's and the j there, so you know it's rectangular form. So, an example. An example is negative 2 comma 5. Everyone should be able to graph that. So if I made this graph, you'd go 1, 2, 1, 2, 3, 4, 5. You would place a point there. Would you guys agree with this? That also can be represented by a negative 2i plus 5j, or a negative 2i hat plus 5j hat. Okay? That is also called rectangular form. I'm assuming the next slide, if I remember correctly, will deal with the polar form. Actually, we're not yet. I want you guys to graph this. One thing I couldn't do on Google Docs was add the hats. So they'll add the little hats on here when you copy them. Guys, we already plotted negative 2, 5. So you don't have to plot that one. We did that one together. Please plot 3 I hat minus 4 j hat and negative I hat plus j hat. So the first one is 3 I hat and a negative 4 j hat. So I will go over 3 in the x direction and down 4 in the y direction. And so my point is here. I hat is the x direction. It's another way of saying x. J hat is the y direction. Guys, the I hats and j hats, if you guys are taking probably physics, this is more of your vector stuff. You guys have seen this probably before in there. Negative I hat plus j hat. Go back 1, up 1. It's like negative 1, 1. So I said, it should take you longer to write your axes or draw the axes versus actually putting the dot or the point on there. Any questions, guys? The other stuff, rectangular, you guys get that. Polar coordinates, guys, I'm going to have to try to use as much as I can the dossary so I can record it, but I'm going to also demonstrate it with myself to show you how it works. Guys, polar coordinates. uses a distance called a radius and an angle. All you are doing is turning a certain angle and then walking a certain radius in that direction. Now, there are types of angles. There's a positive angle and a negative angle. Positive angles are always measured counterclockwise from the positive x-axis. Basically, guys, you always start here. You will always start at the positive x-axis, and if I go counterclockwise, I am going which direction? Up. And if you go up, up is associated with positive. If you go downward, it's a negative angle. So if you go clockwise in polar form, you're going down in a clockwise direction. Positive angle, negative angle. Guys, we are turning. Don't think of it as I'm starting there and following that path of that curve. What I'm actually thinking of is that I am fixed at the origin at this point. When I move an angle, this is how I'm going to teach this. You're going to turn the angle first, then move. So if it's 25 degrees, you will turn 25 degrees, and then you can go 5, because the radius is 5. You would take 5 steps forward. I'm over here. Okay? Which is different than rectangular form, which says I'll go walk positive 3 and then turn and go up 4, right? So it's a different way of moving. You can still get to all the same places. So I took the liberty here that I created the x and y axes, and in not the red boxes starts at 0, and then it goes up to 90, then 180, 270, and then back to 360 if you wanted to. That's normal, right? You guys know that. We've done that many, many times before because that's how we measure angles. The other way, though, is if I still start at 0, but I go downwards, it's a negative 90. So negative 90 and 270 are the exact same place. Or same way you're looking. 180 positive or negative 180. It doesn't matter which way you turn, right? You're both facing the same way. If I go negative 270 degrees, it's the same as moving 90 degrees. Or 0 and negative 360. Or 360 and negative 360. It doesn't matter. Negative 720 is the same thing as a positive 720. It's also the same thing as 360, which is also the same thing as 0. Can you guys agree with this? Because 720 is going around the circle twice. Now, they have two different ways of denoting polar form. And almost exclusively, we'll use the second method here. They say that they can kind of quasi-mix the rectangular form and this idea of polar form by saying the first number is your radius, how far you're going to walk, mixed with the second number being the angle degree that you have to turn. I say don't even worry about this one too much because you're not going to see it. This is the one you're going to see. It's got a number on the outside of like an extended angle thing, right? And the angle goes inside the part that looks like an angle. Those are your two key pieces. Theta, your angle, and r, your radius. So if anything, you can call that theta r. Or r and an angle, theta. So let's talk about graphing polar form. Number one, always start at the positive x-axis. I already told you guys, rotate the angle, theta, in question. If it's positive, you turn in a counterclockwise. If it's negative, you turn in a Clockwise rotation. You turn whatever the amount of degrees is. If it's 1 degree, you take just a little teeny turn. If it's 100 degrees, you take a larger turn. If it's 1,000,000 degrees, you just keep spinning and spinning and spinning until you get to you get to the point where you get to 1,000,000 degrees and you stop. And that's wherever you're looking at 1,000,000 degrees is where you stop. And then in step 3, you get to walk. Now here's the thing. Wait a minute. You can walk forwards and you can walk backwards. See, here's the thing. If the radius is positive or a positive number, that means you're going to walk forwards. But if it's a negative number in front, you don't walk forwards. You're looking this way, but you walk backwards. Here's the crazy thing. In rectangular form, there's only one way to get to your point. Move X, move Y, you're there, you're done, right? But think of this. If I get the spin around, there's actually 4 ways to get to the same spot. I can turn. Let's test this out. I want to get to that spot. If I was using rectangular methods, we would say you're going to go X, I'm going Y, there it is. X, comma, Y. Fantastic. Now, wait a minute. Now let's talk about polar form. In polar form, I'm at the origin, I start at the origin, and I start here. I can turn in a positive direction and walk forward. I'll be there, wouldn't I? Yes. So I can turn positive, walk positive. Now wait a minute. Could I also turn a negative direction all the way backwards to here and still walk forward? So I can turn negative but still walk positive. I can also start in a positive, turn positive. Oh, I just missed my exit, guys.
Turn negative.
But then I stop here.
Oh my God.
If I'm looking in this particular direction, now you can't see this on the video, so here I am. I want to go there, right? I passed it up. And now what am I going to do, though? Go backwards. So now I can go backwards and I'm there.
That's not something you can do on the highway.
So wait a minute. If I'm allowed to go in a positive direction and go basically looking in the direct opposite way, let's see what other colors I have here. Let's use orange. Could I start here and stop here and then also walk backwards, which is a negative direction and a negative angle? So, of these choices, there are 4 of them, right? I can have a positive angle with a positive radius. I can have a positive angle but have a negative radius. I can have a negative angle with a positive radius. And I can have a negative. All 4 of those methods get me to the same X, Y spot. I'll pause the video and we're going to do that all again without the video. The coolest thing about it, or some cool things about it, is the fact that this distance here, your radius, never changes. It's always going to be the same. So if I said it was 5, whether I'm walking it forwards or walking it backwards, it's always 5. The other cool thing about this, and I may be going into the next slide or two, is I'm going to call this theta, right? That's that angle I got to turn if I turn positive. Whatever that angle is also an extension of that looking right on the other side. Isn't this also theta? Why? The angles to the x-axis are the same because they're vertical angles. So technically, if I called this 25 degrees, this would be a 25 degrees, right? So it'd be really easy to say, hey, you go 25 degrees from here to there, How far would it be to go all the way to here? To there. How many is that? 180. And I just have to go how many more? 25. So that means a total of 205. Easy enough. That's the two positive angles. Wait a minute. So if I start here and I only go to here, I'm not going to 180. I'm going 180 minus the 25, which is 155. Or instead of going here, I go all the way to there. I'm not completing the full circle. I'm almost going the full circle, but I'm just going to subtract 25, which is 335. You guys have all the key components then. That's what you have to do. If you can find theta and you can find the radius, you have the key to all four. Whether I'm adding it to 180, subtracting it from 180, subtracting it from 360. Those are the keys. All right. First off, let's graph these. Just graphing right now. Just graph these two. So we are going to use r with a theta inside. So r, the radius is 6. The angle we are turning is 50. So I am still going to start off with the x and y axes, basically. And I am going to turn 50 degrees. Now guys, I'm not going to be sticklers on you need to know exactly where 50 degrees is. Now if I gave everybody a protractor and a compass and a ruler and all that stuff, these should look really good. But we know that 90 is all the way straight up, right? Half of 90 is 45. So we know that, I'm going to take this away, guys, that's about 45 degrees. Can you guys agree with that? So that means when I make my angle or turn my angle, I'm going to go slightly past it, right? That's where I'm looking now. I'm looking at that particular spot from the origin. And now you have to decide, am I going to walk forwards or walk backwards? And how far? How far am I going? In which direction? Forward or backwards? Forward. How far? 6. And then this, guys, is also very subjective. It's 6 at 50 degrees. You're done. It's very subjective because what's 6? It really doesn't matter. I can make this as large as I want, small as I want. Whatever I make that, and I put a 6 on there, and I put a 50 degrees on there, it doesn't matter. It's just a drawing. Right? So that is turning 50 degrees, walking out 6. Done. Everybody's going to look slightly different, but as long as they put the 6 and the 50 on there, we're all good. Try that with the next one. Okay, guys. This one's interesting because this is a negative negative, right? So not only do I have to turn a negative degrees, I also have to walk backwards. So let's figure this out. Systematically, this is a negative 90. That's a bad negative 90. This would be a negative 180. But this is negative 270. Negative 360. I think everybody's okay with that. So that means we're going to fall in which quadrant if we had to say a quadrant? We're in 2. No, we're in 2. Quadrants don't change because we went backwards. So yes, we still have 1, 2, 3, 4 forming the C. So we have to be here someplace. Now is 250 closer to 270 or 180? So I'm assuming it's going to be looking about here, right? Now, here's the thing. I am going to turn to about here. Give or take, it's about 250. Okay? But I'm looking in that direction. But am I going to go in that direction?
No.
And so this is how I like to help myself, because eventually you'll have to find other answers, okay? And so this is what I kind of designate that I'm not there, but it's still kind of important. I'm going to say I'm going to put a dotted line there. That dotted line is representing, I'm looking there, but I'm not there. I actually have to go back. I have to go back how far? So guess what? When I actually do move, it's a solid line. And how far do I actually go? 3. Wait, Mr. Konchak, why is that 3 and not -3? I'm going back. No, that's why it's 3, not -3. -3 told me to go backwards, but I changed it to a 3.
Because you already went to the backwards. Like that, the change is when you hit
Because
the
it's
point.
-3 longer than -3.
It's a distance, guys. The line is 3 long. You can't, we don't have a negative distance. So as soon as I started walking it, I had to start clicking off in positive direction, or positive values. Okay? It's important that we have a 3 because eventually we need to form triangles, and you can't have a negative side on a triangle. So here's the thing, guys. This red angle, I'll change back to red, was the -250, right? But here's the thing. I don't think I would write -250 up in here, do you? No. What is this actual angle here? It's not 90. First of all, isn't this angle here the same as this angle here?
Yeah.
Can you guys agree with that? And if this whole angle to get all the way over to here is 270, or 250, what's left over then here? Leon?
This angle is 70.
70 degrees, guys.
Oh.
Because 250, take away the 180 that it would take to get to here, leaves me with leftovers of 70. Which means that this angle here is also... So wait, oh my goodness, Mr. Konchak. Are you saying there are multiple angles that can get you to the exact same spot? Well, of course. I told you there was 4 of them, right? There's actually an infinite amount. Keep adding 360 to those 4 and you will have every single answer that ever could be. So, your homework is going to be the worksheet that I'm going to give you. This worksheet, guys, listen. The worksheet has the only thing I want you to do, and you guys got to leave yourself room, otherwise you'll have to staple a paper to it. I want you to graph the 4 in polar form, and I want you to graph the 4 in rectangular form.